Hello, future listeners. Welcome to my YouTube channel. Here is another video about moment of inertia of areas, particularly built-up sections that are assembled from structural steel sections, standard structural steel sections. So for the built-up section shown, compute the centroidal moments of inertia of area. So this is the built-up sections, and we have labeled there. We have an rectangular plate 1 inch by 18 inches. Then we have at the lower portion two angles of details 8 by 8 inches, long leg by 4 inches, short leg by 3/4 inch thick. And the orientation is this. You look at the guy there. And we have a channel also which is oriented in this manner. So compute the centroidal moments of inertia, that is moment of inertia with respect to the centroidal x-axis, and the moment of inertia with respect to the centroidal y-axis of this built-up section. So for bar x, it's on the axis of symmetry, which is the y-axis. Bar y would be located. Let's locate the centroidal x-axis, and we will call the distance from the bottom as bar y. So the area consists of 1 by 18 rectangular plate. Then we have two angles, 8 by 4 by 3/4. So the details or the elements of this angle, 8 by 4 by 3/4, would be I bar y 9.37, area 8.44 square inches, bar x 0.949, I bar x 55 inches to the fourth, and bar y 2.94. So we are interested of the area, and the area is 8.44. So 2 times 8.44, then plus the area of this channel designated as C12 by 25. C12 by 25 is this. The area is 7.34. So area therefore is 42.22 square inches. Then we apply Varignon's theorem. 42.22 times bar y equals area of the rectangular plate, which is 18, and half of 18 inches is 9 inches. So bar y1 of the rectangular plate is 9 inches. Then plus 2 times 8.44 for this leg, for this angle. Then times bar y, the distance bar y of angle 8 by 4 by 3/4 is 2.94. So we have times 2.94 here. Then for the channel, it should be 18 inches plus the thickness of the web of the channel, then minus bar x. So the distance from the left edge of the channel to the centroid is denoted by bar x. So it should be 18 inches plus thickness of the web, then minus bar x for this C12 by 25. The area of channel 12 by 25 is 7.34. Then times, as I said, 18 inches plus thickness of the web of the channel 0.387. Where is that? This is the web thickness. TW is 0.387. Then we go down by bar x because that's bar x from the left edge. You look at the orientation to the centroid is bar x, and bar x is equal to 0.674. This 0.674 here. So solving for bar y, it is 8.092 inches. So 18 times 9 plus 2 times 8.44 times 2.94, then plus 7.34 times 18 plus 0.387 minus 0.674, then divided by 42.22, and we'll get 8.092 inches. Then we now compute I bar x. We have to transfer all the elements. Beginning with the rectangular plate, the moment of inertia is 1 inch, base 1 inch, height 18 cube over 12. Then plus the area of that plate, which is 18, 1 times 18, then distance squared. The distance is the distance, the centroid of the rectangular plate is 9 inches above the bottom, and barred y is only 8.092, so the distance is 9 minus 8.092 from parallel axis theorem or transfer formula for moment of inertia, so we have to square it area distance square. So that's for the rectangular plate. For the angular plates, we have 2 times quantity. This axis through the centroid of the angle is I bar x or Ix for the angle 8 by 4 by 3/4. Ix is 55 here. So we have 55, then plus area, which is 8.44, and the distance between this centroidal axis and the centroidal axis, x-axis, centroidal x-axis of the angle is barred y minus barred y of the angle. So barred y is 8.092, while barred y of the angle is 2.94. So again, that distance and the centroidal distance here, axis, is barred y 8.092 minus barred y of the angle 2.94 quantity square. So then plus for the channel, this centroidal axis parallel to this centroidal axis here is the y-axis. So if you look at the orientation, this axis here is actually this axis here. So that's IY of the channel. And IY of the channel is equal to 4.45. So that's why you have 4.45 here. The area is 7.34. And the distance between the centroid of this channel and this centroidal axis is, let's go back to the centroid of earlier, which is 18 plus thickness of the web 0.387, then minus 0.674. So that's the distance of the centroidal axis from the bottom. Then distance from the centroid of the centroidal axis of the entire area is we subtract further barred y. So 18 plus 0.387 minus 0.674 minus barred y quantity squared. And for the angle, it is for the rectangular plate, it's 500.84. For the angles, two angles, 558.05 inches to the fourth, and for the channel it is 683.87 inches to the fourth. So combining, the value is I bar x rounded off to 4 significant figures is 1,743 inches to the fourth. So likewise for IY, this is the axis of symmetry. For the rectangular plate, it is 1 cube. So the dimension perpendicular to the y-axis is 1. That should be cubed. Then times 18 over 12. That's it. Then plus for the angles, we have to transfer. This is I barred y of the angle. So there are two angles. So 2 times quantity I barred y of the angle is 9.37 plus area of the angle 8.44. Then distance. The distance is barred x. So from the centroid of the angle to the left edge is barred x. Then since this is the y-axis, centroidal y-axis, we have to add half of 1 inch or 1/2. So 8.44 quantity 1/2 plus 0.949, where 0.949 is barred x. Take note of that. Then quantity square. Then plus this axis here is this axis actually. So take note, the centroidal y-axis if you flip it and look at this rotation, this x-axis here is actually this centroidal y-axis here. So that's why we use Ix of the channel, where Ix of the channel is equal to 144. So that's why we use 144 here. So combining, it is 199.7 inches to the fourth. So that's it for this problem.